The third topic of the unit is electrolytic cells and electrolysis. We'll study about the process of electrolysis, and electrolysis is carried out in electrolytic cells. In this first slide, there's a diagram in front of you, and this is the basic structure of an electrolytic cell. इसमें हमने electrolyte लिया है NaCl, and कैसे होती है इसकी electrolysis, what is the whole mechanism, we'll see that in the upcoming slides. But यहाँ पे molten NaCl लिखा हुआ है. जब आप electrolyte लोगे, it is very important that in that example you pay attention कि क्या आप अपना electrolyte molten state में ले रहे हो, क्या आप इसको aqueous solution में ले रहे हो, because that will decide कि आपके products, final products of the reaction क्या होंगे, right? Now speaking about the definition, electrolysis होता क्या है? It's a process of decomposition of an electrolyte. Electrolyte can be an acid, it can be a base, it can be a salt. And वो decomposition, वो breakdown into ions हम किससे करते हैं? By the passage of electricity. Thus the name electrolysis. Lysis carried out by the passage of electricity. And we do it, we pass that electricity either through its aqueous solution or molten state, which is very important to mention and keep in mind कि मैं अपना electrolyte aqueous solution में ले रही हूँ या molten state में. Mechanism, what happens inside this cell? This is again the basic diagram in front of you, electrolytic cell की. There's a vessel जिसमें हमने एक solution लिया है electrolyte का. Then there are two electrodes, there's a cathode and there's an anode, and we have a battery, the supply, right? Mechanism based है on ionization theory, simply that when you take this electrolyte, which can be an acid or a base or a salt, and you dissolve it in water or you take it in its molten state, ये electrolyte dissociate हो जाएगा into positively charged ions and negatively charged ions. Then after that, when you pass the electricity, what happens? These ions will start moving, and the direction of movement is as per their charge. What is that direction? Cations, which are positively charged ions, they move towards the cathode. Actually, that is why the name cations. Positive ions, they start moving towards cathode, thus they are named as cations. And negatively charged ions, they move towards the anode, thus they are named as anions. So this is what happens in the beginning. Electrolyte breakdown हो गया उसका into its ions, and those ions have moved towards their respective electrodes. What happens at these electrodes is important, right? Now this happens. Once they reach their respective electrodes, these ions lose their charge. In the solution, after decomposition, they were cations and anions, positively charged and negative. But at these electrodes, they will lose their charge and they turn into neutral atoms, into neutral species. How? If an ion is a cation, it is positively charged. ये कैसे convert होगा neutral atom में? It will have to gain electrons. So this cation which has moved towards the cathode, it will gain those electrons at cathode and get converted into a neutral atom. Gain of electrons is reduction. Thus, in an electrolytic cell, reduction takes place at cathode. What is reduction? Cation gets converted into a neutral atom. Similarly, anion के पास negative charge है. It has electrons in excess. ये neutral में कब convert होगा? When it will lose those electrons. It gives away those electrons to the anode. वही electrons फिर outer circuit से move होते हैं from anode to cathode. So anion gives its electrons to the anode and gets converted into a neutral atom. Giving away electrons, losing electrons is oxidation. Thus, in an electrolytic cell, oxidation takes place at anode. Reduction takes place at cathode. यही सारा description मैंने इस slide में लिखा है. So what happened next? पहले आपके पास ions थे. अब those ions got converted into neutral atoms, into neutral species, because reduction happened at cathode and oxidation happened at anode. This change in an electrolytic cell, this change in the process of electrolysis is called as primary change. So if somebody asks you what is primary change, it is the conversion of ions into neutral species at their respective electrodes. Cations का conversion cathode पे होता है, एनोड्स का कन्वर्जन एनोड पे होता है, एनाइंस का कन्वर्जन एनोड पे होता है. नाउ इन मोस्ट ऑफ देम प्राइमरी चेंज के बाद ही प्रोडक्ट कलेक्ट हो सकता है. इन सम ऑफ देम secondary change is required. What is this secondary change? We'll understand by taking an example. The first example I have taken is electrolysis of molten lead bromide. As I told you in the beginning, molten लिखना या aqueous लिखना important है. मैंने aqueous अभी किया नहीं. I'll tell you what happens in aqueous later. अभी तक जितना हमने पढ़ा है, let's try to explain it by doing this example. We're taking molten lead bromide. In its molten state, these are the two ions Pb2 plus and Br negative. Now positive ion cation moves towards the cathode, bromide moves towards anode. This is the primary change which happens there. At cathode, Pb2 positive will gain electrons and form Pb. Bracket में L लिखा है, it stands for liquid because we are taking it in molten state. That is why the physical state written is L. At anode, oxidation takes place. Br negative will lose this excess electron and हमारे पास Br radical आता है. यहाँ पे छोटा सा dot है जो आपको देखना होगा. यहाँ पे radical, it has an unpaired electron, uneven number of electrons होते हैं. This third reaction is the secondary change. Lead का product primary change में ही बन गया. We can collect lead at cathode only. But bromide radical is highly reactive. Two radicals will combine and form a molecule of bromine. Now this third reaction is a secondary change. As I said, in some cases final product is formed after primary change only, and in some cases we need a secondary change. This third equation in case of this example is the secondary change, right? So overall reaction can be written like this so that you can conclude जब आप lead bromide की molten state में electrolysis करते हैं तब products होते हैं lead in liquid state, in a melted state, and you get bromine gas, but only when you take lead bromide in molten state, right? What happens in aqueous state? Aqueous state का मतलब क्या है? आपने अपना जो electrolyte है उसको dissolve किया है water में, and water की भी ionization होगी. Look at this diagram. We have taken aqueous NaCl. हमारा electrolyte NaCl है, but we have dissolved it in water, because of which हमारी cell में Na positive ions है, Cl negative ions है. Besides these ions, we have H positive and OH negative from water, right? अब ions को move करना है towards their respective electrodes. So Na positive and H positive move towards cathode and Cl negative and OH negative move towards anode. मगर दोनों discharge नहीं होंगे, दोनों में से एक discharge होगा अपने respective electrode पे. Sodium plus and H plus में से एक discharge होगा at cathode and Cl negative and OH minus में से एक discharge होगा at anode. कौन सा discharge होगा? There is a competition. That competition is mainly decided by their relative discharge potential. दूसरा factor भी affect करता है material of the electrode, but mostly it depends on the first one. What is the relative discharge potential? And it has been studied when there are two ions present near the electrode, ion with lower discharge potential will be discharged in preference to the ion with higher discharge potential. Sodium and H positive में से कौन सा discharge होगा cathode पे? It will be decided by the value of their discharge potentials. जिसका कम होगा वही discharge होगा. I have written the reactions here. Electrolysis of aqueous solution of NaCl. NaCl है आपका electrolyte, completely ionized, complete ionization हो जाती है इसकी. Aqueous लिखना ज़रूरी है because you're taking water as a solvent. Na plus होगा आपका aqueous state में, Cl negative होगा aqueous state में. Besides this, water molecule will get ionized, slightly ionized, but it does get ionized into H plus and OH negative. I couldn't find that proper arrow of equilibrium state, so मैंने ये वाला arrow use किया है. Now once this happens, we have the ions in the electrolytic cell and they have moved towards their respective electrodes. अब कैथोड पे क्या होना है? रिडक्शन होनी है, गेन ऑफ इलेक्ट्रॉन्स होना है, मगर किसका? जिसका लोअर पोटेंशियल होगा. एंड व्हेन वी कंपेयर Na प्लस एंड H पॉजिटिव, वी ऑब्जर्व दैट H पॉजिटिव का पोटेंशियल लोअर देन Na प्लस है. दैट इज व्हाई इन दिस केस कैथोड पे Na+ नहीं, H पॉजिटिव डिस्चार्ज होगा, राइट. दिस इज़ वेरी वेरी इंपॉर्टेंट बिकॉज आपके प्रोडक्ट्स क्या होंगे अगर आपको बाय कॉमन गेसिंग बोला जाए सिर्फ NaCl के प्रोडक्ट्स क्या होंगे इलेक्ट्रोलिसिस में. बाय कॉमन गेसिंग वील से सोडियम एंड क्लोराइड, बट नो, you have to ask another question. Am I taking NaCl in molten state or am I taking it in aqueous state? Molten state में product will be sodium and chlorine, but in aqueous state hydrogen takes over, right? So H positive gains the electron and forms hydrogen radical, which is a primary change. Then there's a secondary change. Two radicals combine to give us hydrogen gas. At cathode, in this example, there's a release of hydrogen gas. And at anode, lower discharge potential Cl negative का है, thus Cl negative loses that extra electron and forms a radical, which is a primary change. Radical release नहीं होगा as a product because they are highly reactive. Two radicals combine together and give us a molecule of chlorine gas, which is a secondary change, right? Thus at anode oxidation takes place and we get chlorine as one of the products. So जब आप करोगे electrolysis of aqueous NaCl, chlorine gas is liberated at anode and hydrogen gas is liberated at cathode. बचा क्या? Sodium and OH. They exist as sodium hydroxide in the solution, right? So there are some keywords in this presentation. You will know the definition, you will know the mechanism. In mechanism, you must know that reduction takes place at cathode, oxidation happens at anode. You must know what a primary change is, you must know what a secondary change is. And when you're doing examples and you have to give the result of the electrolysis, you should pay all the attention to this part. Am I taking my electrolyte in a molten state or am I taking my electrolyte in an aqueous state? Because when you take an aqueous state, molecule of water will interfere. Products will be different from what you could guess easily, right? Acidified हम लेते हैं, acidified electrolyte भी लेते हैं. We'll do more examples and we'll see what happens when we change the medium in case of electrolysis.